Good afternoon, sir.
Hi, good afternoon. I hope I am audible.
Yes, sir. Could you please wait for a few minutes, sir? All of our students will be joining.
Sure, sure.
Thank you, sir.
Yeah, good afternoon, Prasanth.
Hi, sir. Good afternoon.
Yes. We'll start the session within a few minutes. Students are joining now.
Okay, sir. No issue.
Right.
Yeah.
Yeah, Sita Monica,
Sir, yes, sir.
I think we can start the session.
Okay, sir.
Yeah, please inform the webinar chair to seminar chair to start the session.
Yes, sir.
Respected dignitaries over the meet, faculty staffs, and my dear student friends. Very good afternoon to you all. On behalf of the student seminar series, I am honored to welcome all of the students who have attended the meet for the seminar. It is truly a privilege to have the opportunity to learn from such an experienced and knowledgeable educators. I am Madhu Maitri from E3EEE. It gives me a great pleasure to introduce the guest speaker of this sixth seminar on Introduction to Autonomous Navigation of Unmanned Aerial Vehicles. Now, I would like to share some specializations about the speaker. Prasanth Kumar Duba obtained his BTech in Electronics and Communication Engineering from RGUKTN in 2016. He is currently pursuing a direct PhD program specialization of communication and signal processing in electrical engineering at Indian Institute of Technology, Hyderabad. He has 2 years of experience in data systems at Center for Airborne Systems DRDO, Bangalore. Additionally, he has expertise in pre-processing of remote sensing data of NRSE ISRO, Hyderabad. His area of research interest includes robust state estimation and mapping for autonomous UAVs, trajectory path planning, and controlling of UAVs, heterogeneous swarm of UAVs. Without any further delay, I would like to warmly welcome our guest speaker who have generously agreed to share their expertise with us. Sir, now I hand over the session to you, sir.
Thank you, Madhu Maitri, for a nice introduction. And thank you, sir, once again for giving this opportunity. One second. I hope my screen is visible. Can anyone confirm?
Yes, 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 it is
Yes.
visible.
Yeah. 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 Once again, good afternoon to everybody who are presenting in the. Today, I would like to give some small introduction about this autonomous navigation of unmanned aerial vehicles. So we already know UAVs is nothing but drones, especially aerial vehicles. So most of the people had how we can see operate through remote controlling and how what is the challenge we are going to see in autonomous navigation. So as a part of our student seminar talk at RGUKT, now I'm going to describe a few things about it. So my presentation, outline of my presentation is as follows. So introduction to UAVs and also what is the design analysis. It's consist of payload and endurance and what is this autonomous navigation, and that one of the technique is how we can do waypoint navigation, a little communication of the system while we are doing up navigation. Then after, what is the entire system architecture in that few blocks like sensors and localization mapping techniques. And finally, what is the current research scope in this particular research area, like multi-UAV system and tunnel exploration under tunnels. These are the few things I would like to share with you today. Now, the introduction, coming to introduction, nowadays you can see wherever you go, UAVs play, sorry, okay. UAVs play a crucial role in many areas like agriculture, healthcare, and also civilian operations and military operations like defense, surveillance, many operations. So we classified these UAVs based on their weights. Many classifications like nano, micro, small, medium, and large. Nano aerial vehicles means it's approximately less than 1 kilogram. We can design a nano aerial vehicles. So mostly these bio-inspired aerial vehicles comes into this picture. And micro means around 2 kg, less than 2 kg. 1 kg to 2 kg we can consider as a micro aerial vehicles. Coming to the small UAVs, you can say 2 to 20 kg. And medium means 20 to 50 kg, and more than 50 we can consider as a large UAVs or heavy payload UAVs we can call. Among all those three, this nano, micro, small, we are mostly focusing for the defense applications like surveillance and reconnaissance. And if you see these micro aerial vehicles uh, coming less than 2 kg, mostly preferable for surveillance applications. So if I say aerial vehicles, I can classify as vertically takeoff and landing vehicles and also normal air vehicles. People already heard about this passenger carrying vehicle that is called PAVs. If you see in the figure 2, we can also classify UAVs based on their base wings and the rotor structures. If you see tricopter, if I say it has a 3 wings, this is the 3 wing structure. This called as a tri. And if you have a 4 wing structure and 4 motors, this is called a quadcopter UAVs. If you further go move on, if you have a 6, that's called as a hexacopter UAVs. And some more other also there. If you have one motor, it's called as a tricopter. If you have a 2 motors, means upside and downside, it's called a coax. That is one more classification of the UAVs. That is a coax UAVs. Apart from this, we can see the fixed wing rotors, and also this is a single rotors, and this is the fixed wing hybrid vertical takeoff and landing. These are for small, some few applications, as I mentioned previously, for surveillance and all. So coming to the another thing, these are for air vehicles. That's called carrying some cargo things, some heavy we want to transport from one place to another places. Like we have passenger aerial vehicles. This is called a volocopter. Currently research is going. And this is the Nava Air, and this is the Boeing, and this is the PAV. This is introduced by Boeing. These are some other few things. What is the UAV and different types of UAVs I would like to share. After this, if I say UAV, so we should know what is the basic components for coming to the design. So this figure 4 is the quadcopter UAV. Wherever you see, this is the basic design of the UAVs in the classification of the UAVs. If I say basic design, then we must know what are the components. That is the first one is the propellers and the motors, and after that ESCs. So what is this ESC? Electronic speed controllers. If I say somebody come and ask you, I want a UAV with a 5 kg weight and also payload of a 2 kg, then now we can design by ourselves a UAV. That I will going to tell. So these are the basic components I have required. And this is the airframe and the landing gear. And this is the flight controller with this is the GPS. It's the motherboard for the UAVs. And finally, this is the battery. So if you consider some block diagram, I have a power distribution board over here that I connect to my battery. From the power distribution board, there will be a parallel connection to the all these 4 wings. This will go like this. From here, I can connect to the ESC, and the ESC will connect to the motors, and the top of the motor propellers will be there. So once you powered on this, with the help of these connections, it will go all the 4 so get the power. It's like a network theory. If I give a input power of it's a battery of a capacity of 12.1, then it has a 4 parallel connections. It's like a 4 loads having 4 motors. Then after this, I have on top of it one is called the flight control with the GPS. So how it will be? So now if we give a power will go to all these 4. At the same time, I have to rotate my motors, and also how this motor will be correlated with one another. So for that, this flight controller will be useful. So from the ESC, we will get one more signal. That is a signal. It will come to fix over this flight controller. Hello, am I audible? There is a network issue.
Yes, sir, you're audible.
So once when I put the power, it will go to the flight controller. From the flight control, we have to assign the motors like this is my forward direction. This rotor should be anti-clockwise direction, and this should be clockwise direction. Then it should be again anti-clockwise, and this should be a clockwise direction. We have to assign the motors like that. Then only when I give the power, it will take off and this for the stable flight. Otherwise, if you give all 4 as a clockwise direction, there is no use. if one rotate clockwise, another should be rotates anti-clockwise for the stability things. So like this, we have to, with the basic components, we have to assemble the UAV. Once we have a UAV, then how we can go for further technical specifications. So as I mentioned, the payload or the endurance, all this decided by the choosing the proper motor and the propellers. If you figure 5, you can see the technical data set of the particular motor, MN500T motors with the kV of 450. Suppose if I say these are the throttle percentage, at each throttle how much thrust it will be generated. For our calculation, usually we will take at 80% of the throttle how much thrust it is generated. Suppose it is generated 2.3 kg. If I consider my hexacopter, it has a 6 motors and all. So with that I can calculate total weight. This 2.3 into 6, I will get a 13.8 total it can generate. And next, one more parameter I want to calculate, that is power required to lift 1 kg thrust. That again I calculate from this data sheet, that is 117.15. So these are the things we are getting from the data sheet of the particular propeller. So furthermore, I can say one more point is endurance. Endurance means the time of flight. If I say one UAV is there, I should also tell to the user how much it will go for the flight with the given power, given battery, and also given motor specifications. So for that, we need the battery discharge curve. If you see this figure 6, this each battery, we are using LiPo batteries, each cell has a max 4.2 volts, and it will go to the saturation value of around 3.5 volts. After that, it will go to, this is the cutoff region. We can see our some people will study PI characteristics of an equation. If we can also decide that this is the active region, this is the saturation region, and this is the cutoff region. Like that only, this is a simple battery curve. If you see 0 to 20, this is a more discharge. After that, it will drastically discharge, and it will go to the saturation region. After this, it will go to the cutoff. So always when you're calculating the time endurance, we need to take a discharge rate up to 0.8 percentage. So that endurance of the system is defined as capacity into discharge rate by average amplified run. So the average amplified run, again we have to calculate using this formula, all of weight into power required to lift 1 kg by total what is the voltage we are giving to a system. So consider this is the example. So figure 7, this is I consider as an exact after UAV. So this all up weight of this one is 5.8 kg, and also power required is 117.15, and the battery we are giving is 22 ampere hours, and this is the 6 cell. Each cell I mentioned as a 4 point, and 6 cell is this the nominal voltage of 22.2 voltage. And the current you can calculate using these formulas. 5.8 into this is 27.18. The endurance with this calculate is 38 minutes. So what is this? So you with this calculation, you are designing your own UAV with how much time of flight, and also what is the payload capacity. Now I mentioned what is this payload capacity. Here I mentioned AUV weight as a 5.8 kg, but once I will go to previous calculations, the total weight it can generate up to 13.8 kg. But always we can calculate the power factor of 2, that is 13.8 by 2, that is around 6.54 kg it will come. So this is manufacturing things, they will tell 13.8. Coming to the practical scenarios, it won't generate, it won't lift to this much capacity. So we have to take always a factor of 2, that is 6.54. So the payload, how could I say, total weight we generated a minus overall weight of this PC, that is 6.54 minus 5.8, approximately is 1.5 kg, and with an endurance of 38 minutes. So what I am going to tell you, this is a simple design. You can design your own thing by, if somebody will come and ask you, I want a UAV with a payload capacity of 3 kg and a flight of a 30 minutes. So with these two things, we can go first. What we need to do is we need to choose motors for the particular thing. After that, which kind of platform you are going to use, either hexacopter, quadcopter, tricopter, whatever it may be. So based on that, in these calculation, you can design your own UAV to flight. Am I audible? Anybody can confirm?
Yes, sir, you're audible.
Yeah. So once this has done, then what I want to do is, suppose with this UAV, suppose if I go with the speed of 7.5 meter per second, so how much maximum distance I can cover? So with the simple thing, v is equal to distance by time, this speed into time, you can get around maximum 17.5 kilometers. So this particular UAV, it will go maximum of 17.5 kilometers with this architecture. So now if I say, then I also focus on the communication system. So what kind of communication, radio communication, if I use, it will go this much distance. So we'll see now. So once now, as of now, discuss what is the different types of UAVs, and after that how we can design our own UAV. Then after now we have a UAV with us. Next point is we have to move one point to another point, that is called navigation. So in the UAV navigation, there is always two ways. One is remotely controlled and second one is autonomous. So in the remote controller, always we need one remote which is operated by the person, and this is the receiver we can communicate with the UAV. So these two will communicate through wirelessly using RF communication. So here the thing is how long we can control with the remote. So using our analysis is the line of sight, means we can see the UAV up to around 1.2 kilometers at an altitude of 70 to 80 meters. So if that altitude, if you go beyond 2 kilometers, we cannot see the UAV. So it's very difficult to control with the remote of UAV. So there is a need of autonomy of the UAV, autonomous navigation. So then there is a coming to the picture. This is the autonomy of UAV. So here this is simple our laptop and also UAV. These are the two transceivers. It's called as a telemetries. This is one trans receiver and this is to one trans receiver. This will be connected to UAV and this will be connected to the UAV using the universal asynchronous receiver and transmitter, which a baud rate of 57600 baud rate. They will be communicate with these things, and this they will anyway, radio communication will be established. This will work beyond visual line of sight, that is 2 kilometer to up to 100 kilometers. So if I say I have a UAV and also I want to communicate with UAV using this radio communication, then how we will communicate and how we will go for a autonomous navigation. So this is the one of the technique is waypoint navigation. As I mentioned initially, I have a UAV with onboard GPS and also one radio telemetry which is integrated with that. And now I have one ground control station, that is my laptop, which is connected to the one trans receiver. After this, once connected these two, we need to do some calibration before going to the flights. Calibration like GPS is there, inside compass will be there. So compass calibration we need to do. And one more step is axial calibration, means here I cannot put the calibration techniques. Okay. So compass calibration and axial calibration means if I put my UAV as a forward, if I say this is my forward direction, I will put forward and after that I will slightly left and I will have to train my system to do this will be left and next right and up and down. Like that, have to do the calibration before going any flight. So these are the basic things we need to do in the calibration point. So once we have calibrated and also this communication link is established between the ground station to the UAV, then we have a open source software that is called QGC, ground control station. Once we open, we can see the first GUI itself is the current location of UAV like this. This is the arrow marks we'll get. How we will get the current location? Using the GPS. Always GPS will give the current location of the particular object where it will be. It will give the latitude and longitude. So once we open that, we have to give the path like this. So where we need to take off, that point we have to assign, and also next where you want to go. If I here I given one more waypoint, this is called a waypoint. While you're giving waypoint, what are the parameters we need to assign is what is the altitude you have to fly, and also what is the speed you want to go, and also what is the hold of the second. Once we reach the point, how much minimum 2 to 3 seconds it should be there hovering, then after it will go to the next point. So like that, you have to create one more waypoint. Here also you have to give some parameters: altitude, speed, and also hovering time. Then after, it has to go to land at somewhere. Otherwise, one more option also there, it will come back to the initial position, that is called return to the launch. So this is the simple, we have to give a path. This is called as the path planning. So once we are giving like this path planning, suppose I have assigned a path plan for a 2 kilometers from here to the here, and I assign. So before going to the initial flight, just will check whether it will be hold for or not. So coming to the communication system, as I mentioned, these are the communication parameters at which I have used the radio communication with the following specification: what is the transmitted power, IRP, bandwidth, and the SNR. So we'll go for a small calculation. Means I have given assign a flight for 1.5 kilometers. Whether my communication system will be hold or not, I am checking now. For that, I need to find the range. You already know that this Frisch equation, that is PR is equals to PTZT gr lambda square by 4 pi r whole square. Where PT I will mention that 1 watt and ERP is 4, means this is the product of transmitted gain into the power. From that I will get the GT is equals to 4, and I have considered GR is a 1 unity, and with the help of the frequency I will know the lambda 0.327 meter, and SNR I consider at the 41 dB. So and not, this is the AWG noise I have considered, that is 10 power minus 20, and bandwidth I already mentioned. With this I will get the PR. So with the help of this PR, I will calculate the range. That is, I am approximately get 10.7 kilometers. So my communication system is hold for the 10.7 kilometers. And also I have assigned a path for already 1.5 kilometers. So this is the small test we have done. This is from hospital to our hostel area. We have conducted the experiment. So you can see this UAV is take off at the hospital, and continuously we can track it. I'm tracking it where it is going. You see, this is the altitude 70 meters, and it is the distance it is going, and then the speed I have given is a 7.5 meter per second. I hope this video is visible.
Yes, sir.
Yeah. So it is landed over here. This is our test bed where it is landed. So previously you have seen the live telemetry of the UAV, and now it is coming and landing over our Tihan test bed. So it is carrying some medicine from hospital to the here. Once it has landed, some person can come and collect it. So here you can see, this is the simple autonomous flight of UAV from one point to the another point. First, for that, what you need, the basic design of a UAV. Once the design is ready, then with the help of this waypoint navigation, we can move from one point to the another point. So you can also, people can do in our campus from hospital to some other a small distance for 500 meters and 200 meters. We can also navigate. There is nothing difficulties in this. So this is the first waypoint navigation which comes under the autonomy. So in this, I have considered there is no obstacles in my path. If you see from one point to another point, I don't have any obstacles. So suppose if there is an obstacle, that we'll check later. So first, these are the experimental observations. So initially I have taken some VI and distance and velocity. With that, theoretically I calculated, experimental I got 23.3 endurance. And theoretically at the same discharge capacity, with this calculation I'm getting 29.13 minutes. So there is a tolerance. If you see from theoretical to the practical, there is a 5.83 minutes. So how we can validate these results? As I mentioned, that endurance is equals to capacity into 0.2 V by all of weight into the P. we found that there is a issue with the P. Power lift to power required to lift 1 kg initially we consider as a around 118 watt per kg. So how we can do? So this is a simple mathematics. Again, we are going back. I consider as a delta T, that T minus some delta. These are the mathematical formulations. From this, we found that it's required the additional power to lift per 1 kg is 18.09. So finally, we came to know that the total power required to lift 1 kg is around 135 watt per kg. This how we can validate the our theoretical and the experimental results. So as I mentioned, as of now we consider there is a free path, there is no obstacles in the navigation things. Once there is obstacles, we are moving, suppose from one point to another point, in between buildings will become, some other things, obstacles will become. Then how it build the navigation. So this figure 9, the block diagram shows the overall UAV system architecture. So for that, can anyone say whether this system is the open loop system or a closed loop system? Hello, am I audible?
Yes, sir, you're audible.
Yes. Okay. So control system you people studied, right?
Yes, sir.
Okay, okay. Okay, no issue. So if you consider this overall system, this is the open loop, then you can see the inputs, the feedback again is coming to the inputs. So hence we can call it as a closed loop system. Okay. So the first block we can consider is the sensors, that is called the inputs. So in coming to this particularly aerial vehicles, the basic sensor we are using is this IMU, stereo camera, and the LiDAR. And after that, we are getting the data from the sensors. We need to do the estimation part. That is called multi-sensor estimation, state estimation, nothing but localization and the mapping. And after this, when we get the data about the environment, we need to plan according to the plan. Like we should know the first environment from the sensor data. After that, you need to estimate the current position of the UAV. From that, you need to pre-plan the path. Suppose if any obstacle is there, you need to replan it. After this planning, trajectory generation, again it will go to the controlling part. That previously I mentioned that one flight controller will be there. It will be control all the position and the attitude. The position means attitude, position control means um, sorry, XYZ, and also rotation around the XYZ. This usually we call it as a roll pitch. In coming you can come to know, I will tell you. So after that, this controller, then the instruction will go to the actuators, that is called the motors. Based on that, motors will behave either clockwise or anti-clockwise towards the goal. And again, if it is reached one point, then after the instruction go to the inputs, that is called the sensors. So it is a overall system block diagram of the autonomous system, and we can also call it as a closed loop system. So now we can deal with the basic sensors. As I mentioned, IMU. What is this IMU? So this IMU is internally consisting of three devices like accelerometer, gyroscope, and magnetometer. This figure 10 is the IMU. What is this accelerometer? Accelerometer will always gives the acceleration around the x-axis, y-axis, and z-axis. From this IMU, we'll get the position. How we'll get the position? These IMU measurements, or you can see this is the angular velocities and this is the acceleration. We know that acceleration is double derivative of the position. Therefore, if you want to know the position, we can integrate these values. We'll get the position around the x, y, z. So again, here some always there will be bias and the noise. If you do integration, there always be some noise will be there. So gyroscope, what is the use of this gyroscope? This gyroscope will give the how much rotation it is happening with the respective axis like x, y, and z. I am telling rotation means that is what the rotation around the x-axis we can call it as a roll, and the rotation around the y-axis called the pitch, and the rotation around the z-axis called as a yaw. And this magnetometer you can use it for the south and north pole detection towards the movement. So this is how this IMU gives the data for us to estimate the position of the current vehicle. So we take the sensor data, estimate the state. If I say like that, how you can do? So this is the, if once you are dealing with the sensors, the GPS will give the data of like this: latitude and longitude and altitude, current altitude with respect to the mid-level sea. And coming to this IM, you already mentioned that acceleration at x-axis, y-axis, and z-axis. These are the time stamps, means particular time it will give this data. So with this data, how you can estimate the position of the vehicle? So this is the block diagram. You can see we used the basic filter that is called the Kalman filter. This Kalman filter will help you to predict the position of the object. So this I am not going to tell you now. This is the full mathematics. This the Kalman filter is the basic filter to predict the any state in autonomous vehicles. So this what this figure will show. So this is the data we collected in our campus. From one point to another point we are moving. So while first we are moving from initial point to the ending point, we get all this data. From that data, with the help of this Kalman filter, we predict the object position. So this figure you see, this blue line is the truth value. That means that is the truth, ground truth value, this from this point to the another point. This red curve will show the estimated with the help of the Kalman filter. It's like a simple learning algorithm. So we have this data bring to the system and we will train. After that, we'll get the estimated value. This is how, with the help of this GPS and the IMU sensor, we can estimate the state. How? It's like a one of the part in the autonomous navigation with the simple these two sensors. Next, moving further, I introduced one of the sensor that is called the stereo camera. So there are many stereo cameras available, and I have chosen that is called Intel RealSense D4335. It has a maximum range of 10 meters. So these are the stereo camera. With the help of stereo camera, what will you do? One of the application I'm telling is object detection from one point. So if you consider this is my left and this is my right camera, so this is the distance between the left camera to right camera, that is called the B, that is the base length, and this is the Z, that is the distance from the object to the camera. So using the simple triangle method, if you consider from here to here, this is one triangle and this is the one triangle. Using the binocular theorem, you can get this relation, that is this Z by O. If you consider this triangle, this is B by 2, and if you consider this triangle Z by B by 2, if you sum all this thing, Z by B is equals to B delta X, where delta X is equals to X as a pixel, that is receiver signal pixel number into pixel size. Receiver signal pixel number into, usually pixel, 1 to 25 6 will be there. This is the pixel size which will be given to the particular manufacturer to the respective cameras. So this is how we can calculate the Z, that is equals to B into this base length by delta X, where B is the focal length of the particular camera. So maybe this mathematics may be confused you. Here what I am doing is, we have some sensors, how we are using those sensors for our navigation part. So here you can see that these are some of the results. We are identifying a person at a distance from 0.6 meters from x-axis, y-axis, z-axis. This stereo camera will give the information XYZ about the object like this. So first we have the IMU and GPS data, we are estimating predict the position of the vehicle. Then with the camera, stereo camera, we are identifying the object distance. So these are the state estimation. Next step, if I say localization, what is this localization? Localization means the current state of the UAV. If you see figure 15, it will give to the 6 degree of a freedom of UAV. If you consider X, Y, and Z. So rotation around X, Y, and Z. These are the 6 degree of a freedom. Aerial vehicles. Suppose some people are doing their own research on the ground vehicles. In the ground vehicles, there will be a 4 degree. There won't be a remaining 2. only around the z axis only the rotation will be there, x and y, there won't be no rotation. This is called the localization. Once localization then the mapping. What is this mapping and what is this simultaneous localization mapping means? I already mentioned that if you are going in an environment from one point to the another point, we need to know the current state of the UAV at every instant of the time. Suppose if you consider xk minus 2, you have a current state. Then if suppose next moment if you go to xk minus 1, you need to know the current estimate. So from here we need to map the previous state also. This is what? This is estimated at the x is equal to k minus 2 and x is equal to k minus 1. Also we have to estimate, and also we have to map the previous thing that we can assign as a landmarks. Like this, if you go further, wherever you go UK, at each time instant we have to predict the current state and also map the previous state. That is called the localization. Simultaneously we are localizing and mapping. That is called the SLAM technique. So this is some example of this system of UAV as a camera and also GPS and IMU. With this, how this is the direct visual SLAM. If you are moving in a city, so we'll get all the information about the city. It's called using the SLAM. This is a 3D SLAM. It's a simple example. So as of now, we have seen if any obstacle in an outside environment, how we are dealing with the sensors and all. Suppose the recent studies happened inside buildings, inside environment, how the UAV will be navigate. 1 second, why stuck? So this is the platform of which comes under micro aerial vehicle less than 2 kg. It's equipped with, as already mentioned, that this is the camera, Intel RealSense, and also some flight controller, and also the onboard processor, which fully equipped with UAV, less than 2 kg, is conduct the experiment in an indoor environment. You can see this video. So this is what, from one point to another point, before going to the practical experiment, we need to do some simulation part. This is the simulation they have done, is one of the research from the MIT University. So they have estimated the next position. It's called a trajectory planning. From one point to another point, you can see it is avoiding the obstacles and also it is going inside a building. This is his goal, and next state also it's predicting. It's called a trajectory path planning. These are the simulation results. So they have initial, 1 second, sorry. If you see, this is the starting point and this is the ending point. From starting point to ending point, we need to obtain the trajectory path. So this is how, if you know the environment, we can directly give the wave. The environment is not known. In that case, we need to train our sensors to get the free path to move from one point to the another point. That is called trajectory path planning. You can see once the simulation has done with this platform, they have conducted the experiment with the velocity of 3.3 meter per second. This is the indoor environment. And also here, one more consideration we have done is obstacles are static only. There is no movement in the obstacles. So the UAV has to go reach the goal over here from one point to the another point. Here the goal is over here. It is started from here. From here to here, it will be navigate. It will finally reaches over here with the high velocity compared to the previous one. So this is how navigation is taken from one point to the another point in a dynamic environment also. So as of now, I have given some basic idea. I hope you people understand the basic idea about the autonomous navigation. What is GEL's current scope? If you see, multi-robot system means, as of now, I dealt with single UAVs. If you consider multiple UAVs, that is called the swarm of UAVs. What is the homogeneous and heterogeneous? If I consider same platform with the multiple, that is comes under the homogeneous. If the Suppose I mentioned tricopter, hexacopter, quadcopter, like all these different varieties if I consider, and if I want to navigate in a area, then it's concerned the heterogeneous UAV spams. So now the current scope is there will be a lot in this spam of UAVs for a surveillance applications. Suppose if I give an example, some military combing operation has to happen. Suppose some terrorist attack is happened inside a building. So suppose instead of sending to the army, I will send a 10 drones, which one is like a leader drone, it's a big and the remaining 9 is a small UAVs. What will you do is first small UAV went into inside, and it will be with the help of the camera will get the information what is going inside. Then that small UAV send information to the nearby UAV, and next nearby UAV sent to the next. It's like a chain. So there one of the application of the swarm of UAVs will become. So the challenging task is the coordination of all these UAVs is very difficult task. So this is one of the current research scope. And second one is, suppose if I consider tunnels, underground tunnels, and inside how it will be navigation itself is little challenging task. And second one is, okay, we are navigating fastly. Suppose if you want to land in the dynamic platform, suppose if you can see our military areas, some ships will be there. Suppose UAVs has to be take off from one ship, and he has to monitor in the boundaries, survey lines, and again it has to come and land over the ongoing ships, like the dynamic platform. These are the current scope we can explore more. So thank you. So finally, what I want to convey is this UAV is currently very key role in all the areas. So anybody can do their own design, simple design. We can navigate from place to another place. So if you have any queries, you can ask me. Thank you. Hello, am I audible?
Yes, sir, you are audible, sir.
Okay. Any queries from students?
Good afternoon, sir.
Yeah, good afternoon.
Sir, I'm Ashrefan from Triple E3.
Okay.
So nowadays, autonomous drones are coming with SDKs, right, sir?
Yes.
Market made. Yeah. So can we build our own autonomous drone with our sensors like we like? And how can we dump the software in that, sir?
Yeah. So as you mentioned SDK, first you have to choose your own sensors, what sensors, and also what is your application first. You have to define. So based on that, suppose if you choose an only one camera and simple, if you want to navigate camera and IMU sensor, if I say with that many things we can do. First you get the sensor data, you have to process it, what you want to do. Then on board one processing will be the processing unit is required. After that processing unit, you need to dump in the particular thing SDK.
Okay, sir. Thank you, sir.
So I would like to know anybody interested to work in the field of UAVs. Okay.
Yeah, yes, sir.
Okay, may I know means what is your interest in UAVs means? So coming to UAVs, there are many applications nowadays. You can see photography, and also coming to the particular surveillance, cinematography, and civilian applications and also agriculture applications. Many applications are there. So anybody can tell me, so which area you are planning to interested to work like that?
Yes, I am interested in agriculture sector.
Okay, so means how we could what is your goal means?
For doing works in less time with less manpower.
Okay, that's fine. Can you elaborate briefly? Means work means what kind of work? Suppose you are UAVs as of now, you can say spraying fertilizers and all those kind of works are what kind of works you want to do? Or you have
No,
any innovative ideas to?
for spraying fertilizers and for irrigation purpose
Mm-hmm.
and
Okay, that's great. And in many areas, we can see surveying also people are doing using the UAVs, surveying lands and all. So we can also explore in that area. Okay, anything else? I hope this lecture will be some give some basic idea about UAVs. Maybe it will be useful for you. And if you have any questions and any queries, you can contact me through my mail ID also. I hope we may end this session if you doesn't have any queries.
Okay, sir. Is there anything else you wanted to share or cover before our recapitulation, sir?
Mm, sorry, I didn't get you.
Sir, is there anything else you wanted to share or to cover before our recapitulation, sir?
I covered as much I can. Nothing from my side. If you have any queries, I can share.
Okay, sir. Thanks.
Thank-
A special thanks to our guest speaker, Mr. Prasanth Kumar Duba, for accepting our invitation and for being here with us today. It was really informative seminar in true sense, sir. I am pretty sure the precious knowledge you gave us will definitely help us in our studies and future, sir. I would also want to thank our head of the department and Dean Academics, student seminar series team, and supporting faculty members. I will end my vote of thanks speech by thanking you all once again.
Okay. Thank you all. So the person you are already sorry. Finally, before I conclude, I want to say so coming to UAVs, more focusing on the things like I would say computer vision. So some people already told that they want to work with the SDK. So if you want to dealing with many sensors, you need to do the computer vision, focusing on more computer vision, how you get the data and how you need to process. And second one is coming to the controlling part, as we already studied in the BTECs, mostly control system. One is the best controller, that is called the PID controller. So you must focus on that for controlling of the systems. And more else, if you have any queries and also in further you need, if you are really interested in UAV and if somebody wants to work with me in my area, please contact me for any internship kind of things. Thank you all. Thank
Thank
you,
you,
sir.
sir.
Thank you, sir.
Can I leave now?
Yes, sir, sure, sir.
Yeah, thank you.
Yes, sir.